Good morning, everyone. Today I'm going to talk about ecological succession in mangrove plantations of the Bangladesh Delta. This talk is basically part of my PhD ongoing research under the principal supervision of Professor Catherine Lovelock. So welcome to my presentation. Mangroves are salt-tolerant coastal plants, which can also tolerate tidal inundation. And mangroves are available in tropical and subtropical coast of the world. And mangroves provide many ecosystem services, such as coastal protection, land stabilization, and blue carbon sequestration. Unfortunately, 30 to 50% of the global mangroves have been degraded mainly because of anthropogenic pressures, such as coastal aquacultural practices. And to respond to this problem, many countries like Bangladesh have started mangrove plantations to overcome this situation. Bangladesh is a deltaic country, and Bangladesh is a part of tropical country. This is also rich in both natural mangroves and plantation mangroves recently. So the country, the western side of the delta is, you see in the left side of the Bangladesh map. The western part was rich in natural mangroves, but the eastern side of the delta, there has not been any mangroves until the 1960s. And the western coast was more stable, and the people, those who are living behind the western mangroves, they have been protected from natural calamities. To see these benefits, the government of Bangladesh have decided to plant mangrove species on newly accreted coastal lands. And government has primarily started plantation activities by using two pioneer species. One is Sonaracia pitala, and another one is Avicennia officinalis. And if you see the following picture, you see the seedlings are going to be planted in the nursery, and then established seedlings are going to be planted in the newly accreted coastal lands, and the planted seedlings are going to be established gradually. That looks like a natural forest at a certain stage. So today, there has been a significant part of plantation mangroves have been established in this delta. Unfortunately, there has not been any record how much of those planted mangroves have been established to date, in particular the areal extent. And is it possible to establish the plantation mangroves to that of the natural mangroves after a certain time? And then what's about the community structure of planted mangroves? And what's about the species richness? So to address all those questions, I have established broad research questions like, can planted mangroves achieve forest structure and function similar to natural mangroves through ecological succession? And for these, you see in the figure A, where is Bangladesh? And in figure B, that is our sites. We considered the plot level data, plots from the eastern coast. And then if you just look at the figure B and left side, you see the dark blue color, that is the natural mangroves. And beside that, we have set out our control sites. And that is figure C. It's just the example of our transects. And we have followed a specific protocol that is applicable for this country and this region. And we have set out nested circular plots. In total, we considered 72 plots for our plantation sites and 15 plots for our control sites. We calculated our aerial extent by from the global mangrove watch data sets by ArcGIS tools, and we calculated biomass by allometric equations after recording the DVH and height from the plot. And we assessed community structure by non-metric multidimensional scaling. We also recorded all the species from all the plots. regarding the aerial extent of plantation mangroves, although there has been a very few mangroves until 1960s. So if you look at the figure A, that is the present status of both natural and plantation mangroves in this delta. And if you come to the figure B, that is the established mangroves to date. And we are very happy to inform you that today 280 kilometers square of planted mangroves have been established in this delta, which is equivalent to 7.5% of the nearby natural mangroves, which is commonly known as the world's largest mangrove forest, Sundarbans. And my results is equivalent to 0.21% of the global mangrove coverage. Our data sets showed that plantation achieved mean above ground biomass from 15 to 158 megagram per hectare. And if you look at this plot, in the x-axis, that is the age of the plantations. And in the y-axis, that is above ground biomass in megagram per hectare. So our data sets reported that plantations might achieve equivalent biomass recovery at the age of 20 years. And our findings also supported by some previous findings. In case of Florida, plantation achieved similar biomass by 20 years. In case of China, it was for 15 years. And in Philippines, it was for 25 years. And Indonesia, it took 40 years. And Indonesian mangroves was high diverse mangroves. So our findings is quite relevant to the findings of Florida. And if I go to the tree density to assess the succession, the density of trees ranged from 246 to 330 trees per hectare. And similar to the previous plot, if you see the x-axis, the age of the plantations, and y-axis, the tree density, then plantation achieved the similar level of equivalent tree density at the age of 39 years. And the reference line, if whatever you're seeing here, that is the mean value of our mean value that has been considered from the natural mangroves, I mean the control sites. So our findings, and from this plot, we see that the plantation density tended to be down when plantations become older or matured. It does mean that it's mainly due to the cell thinning in older stands and intra-species competition. And our findings are similar to the previous results of Florida, Philippines, and Indonesia. We also assess the community structure. So in the left side figure, if you see that the community structure is higher in case of older plantations than in the younger plantations. And if you just look at the right plot, so from these NMDS, non-metric multidimensional scaling, we found that the mean NMDS value of 0.10 years, if you consider that, and you just see 30 to 40 and greater than 40 years, so the higher the age, the higher the distance in between the mean NMDS value of the plot. It does mean that older plantations are more complex in structure than the younger plantations. And we recorded 19 species from our plantations and 23 species from the control sites. And mangrove tree community structure, just see the right figure. Mangrove tree community structure was different in the plantations than in the natural forest, because one of the planted mangroves species, Sonaracea apitala, was the dominant species in the ecosystem. We also assessed some mangrove associates from in our study, because the mangrove associate species is a good indicator for ecological succession. This is the first time that from the plantation mangroves in Bangladesh, we recorded 4 different mangrove associate species. If you look at the left side figure, you see that the 4 associated species tended to be increased when plantation becomes mature. Only the exception of pandanus that might be impacted because of the tidal inundation level. As plantation becomes matured and over matured, sometimes it's quite tough to reach the tidal water to the land side. And if you see the right side figure, you see that it's still the mangrove associates species number, species richness per plot is higher in natural mangroves, followed by the western coast. So these west, central, and east, this has been basically considered from the plantation plots. And so it's still the western coast of the delta seems to be richer in species richness. And that might be because the western coast is very close to the natural mangroves. And in my another chapter, I see that the salinity is also in moderate to low salinity level, where the mangrove associates might be suitable to introduce. We conclude that while forest structure can be achieved in less than 40 years, because our data sets have been recorded from 5 to 42 years of plantations, but species richness may not be reached even by more than 42 years or 40 years. And older plantations are more complex in structure than younger plantations. And the availability of 4 mangrove associated species in our study sites might be a good indicator of ecological succession. And the outcome of our research will help in future planning conservation and restoration program for high diverse country like Bangladesh. And I don't have any reservations to show my acknowledge to the University of Queensland, and then University of Chittagong in Bangladesh, that is my home university, Bangladesh Forest Department for their in-kind supports during the huge and ambitious fieldwork during this pandemic. And then I'm also grateful to Sarah for the arrangement of such an awesome and fantastic conference where I have been able to share my preliminary findings of my PhD research. Thanks everyone for giving your time and showing your interest too.
Lane, great talk. I've got a few minutes for questions.
Certainly ambitious work. Fantastic. I have a question. The other species that had come up, Deris dalbergia, these are not exactly mangrove species. Maybe Deris, but dalbergia, I'm not so sure. I'm just wondering, do you have similar sort of associations in the natural forest, natural mangrove?
Yes, unfortunately, I couldn't show that result. I got the similar 4 species in the natural plot area. And in addition to these 4 species, I recorded 3 more species, 7 species. So I have not been able to show that one here. All those 4 species are available in natural forest.
Is it that you find, for example, dalbergia is a big tree, it's found in the mainland as well.
Yes.
Do you find that these associates occur further down the line, not proximal to the coast, sort of not associate, but further inland rather than near the...
Okay, I understood. Thanks. It's a good question, really. The associates density actually seems to be higher towards the landward zone. And what's happening in Bangladesh, in between the coastal embankment and then sea or river, there has been a newly accreted lands, and government are targeting to plant on that newly accreted land where the grass communities is coming. So once the sites have been established, once the age of the plantations is higher, the associates are coming relatively in higher number than the seaward zone. So you are right that towards the inland and mainland, the species richness and the number per plots are higher. in comparison to the seaward zone. Exactly. In between the, like you can say, the intertidal zones, sea, mid position, and landward. And that would come up in my next chapters in details.
Thank you for that talk. It's very interesting. I understand in Bangladesh there's the twin issues of the erosion of some of the rivers and also from sea level rise. Is this mangrove restoration assisting in some of those problems?
Yes, Bangladesh is known as Bengal Delta and ZBM Delta, that you have told, that river dominated delta as well. And yes, this restoration program or afforestation program is going to be quite helpful for the coastal people, those who are living behind this area. And as you know that in our country, every year we face some tropical cyclones. And reality is that where there is the established mangroves, people behind those mangroves are going to be protected themselves better than in the barren area or exposed area. And obviously, Bangladesh is contributing here in case of coastal protection and regarding the blue carbon sequestration as well under the Paris Agreement. I mean, nationally determined contribution under Paris Agreement.